So for this example, the system x prime equals, that's vector x prime equals matrix A times vector x, and A is this 2 by 2 matrix, 1 1 in the top row, 4 negative 2 in the second. Verify that vector x, which is c1 times this vector e to the negative 3t, negative 4 e to the negative 3t, plus c2 e to the 2t e to the 2t, this vector, is a solution. You think it is? Well, you're right. And it is because of the superposition principle and the fact that we've already worked these out, but let me show you that it is, in fact. X prime would be, if you took a derivative of this is just a constant, so if you took a derivative of this vector, negative 3 e to the negative 3t, and then 12 e to the negative 3t. So actually you could just factor out the negative 3, and that's what I did here. It is what I said, but this might be a little more convenient. We're going to wind up with it anyway. The derivative of this, remember this is just the sum, so the derivative of the sum is the sum of the derivatives. So the derivative of this vector is 2 e to the 2t, 2 e to the 2t, factor out the 2, so negative 3c1 times the first vector plus 2c2 times the second vector. And if you added all that up, you would indeed get negative 3c1 times e to the negative 3t plus 2c2 e to the 2t. Similarly, you get the same thing in the second slot. And so, let's see what happens if we multiply vector, that's x prime. Let's see if matrix A times vector x is the same. So we take our matrix A and multiply it by this vector, and before I multiply it out, I'll go ahead and call it c1 e to the negative 3t plus c2 e to the 2t in the top slot, and c1 times negative 4 e to the negative 3t plus c2 e to the 2t in the bottom slot. So if we do that, let's see what we get when we multiply. 1 times this plus 1 times this. Okay, now let's see what we're going to get. We're going to get, if we add the like terms there, we're going to get c1 e to the 3t minus 4c1 e to the negative 3t, so minus 3c1 e to the negative 3t. And then add up these two like terms, it's this one plus 1 times this one, so that's 2c2 e to the 2t. Alright, now let's look at the second entry. How do we make that? 4 times this minus 2 times this, and let's see what we come up with. 4 times this is 4c1 e to the negative 3t plus 4c2 e to the 2t, and then minus 2 times this, well, negative 2 times negative 4 is positive 8, plus that 4 makes 12 c1 e to the 3t, and then we got 4 times c2 e to the 2t, and then minus 2 times c2 e to the 2t, which would give us a total of 2 c2 e to the 2t. And look, matrix A times vector x is this. X prime is this. They're identical. Therefore, it's a solution, which is exactly what we wanted to show.
What are you doing?
Well, I'm showing that this, by the superposition principle, and also by actually grinding it out, I ground it out this time, but is a solution to this equation. Recall in the previous example, we showed that this was a solution, showed that this was a solution, therefore a linear combination of those two is also a solution.